I had a comment here from Wonderloo about a video, and I just couldn't let that go. The video was from this guy, GM CDXX. That's Roman for 420. So yeah, I guess he's smoking something. It was about this video, and I also had a look at that video. So let's just see what he has to say.
Alright, I'm going to show the problems with Polaris in a heliocentric model. So, from where I'm at in California, when the sun rises and sets, day and night, the North Star is opposite the ocean from where I'm at. And it's in between 0 degrees and 90 degrees in the sky. Somewhere about 45, give or take.
Not at your place in the world. I'm going to show that later.
15, 20 degrees. So, I don't know.
That's clear. You don't know.
Exactly.
Exactly.
But in their model, it says the angle between Polaris and the horizon due north from where you are standing. That's to find out your latitude. All you have to do is estimate the angle between Polaris and the horizon due north from where you are standing.
Just make it clear, this video of his is recorded in 480, and this is just the same I saw on his video, so I didn't crop this. This is as it was in his video.
For example, at Earth's North Pole, Polaris is directly overhead, which is 90 degrees above the horizon. Okay, so it's directly above the North Pole.
Yes, it's directly above the North Pole.
Right. So it's directly above this, right?
Yeah.
Now, from right here, I would be right here in California, right about here where the sand is.
I got San Francisco on my model. That's close enough for this one.
This would be, I don't know how many thousand miles below the curve. So, somewhere, just if you just move over just a little bit right here, from here to here, that's at least 50 miles.
Yeah, 50 miles. That's less than 1 degree.
And that's where the horizon's at. And you can't see below the horizon, right?
Right.
But this is well below the horizon. From
North Pole is below your horizon, not Polaris.
From my perspective. But Polaris is at an angle in the sky between 0 and 90 degrees. I don't have the exact degrees.
I'm going to show you that in a few minutes.
Now just think about it. It doesn't matter how far out this goes, because Polaris is said to be 433 light years away.
Yeah, that's not on top of North Pole. I'm just going to skip a part here, because now it just calculates how far it is. So just get to here again.
Okay, so even though I'm here, it's below the horizon, so I can't see it.
Again, you can't see the North Pole. Polaris is 433 light years away.
But they're trying to say because it's so far away, now I could see it.
Yeah.
Why would I be able to see it if it's below the horizon?
It's not below the horizon.
From my view. But when I get a star map, like star chart, it's up in it's at an up angle. It's not below the horizon.
Yeah. Right.
Do you understand?
No.
Do you see how This goes against basic geometry.
I see how this goes across your understanding of the globe model.
If you understand trigonometry, I mean just angles and degrees, right?
Wrong.
But the Earth is spinning like this way, right? It's supposed to be spinning that way, and that's the axis. So this is kind of hard to show on like a two-dimensional screen.
Yeah.
That's why you need to make a 3D model.
I did.
So as if this spins, okay. Sun, say the sun's over here where my arrow is.
To the right.
And it's not ever moving, just like the North Star is never moving. They're never moving. We're moving, right? We're moving towards it. That's why the sun appears to come this way. We're moving this way, see? But guess what? If the North Star is up here and I'm here, my view of it is changing.
No.
See? Let me go here. Now it would be a different view. It doesn't matter how far away it is. It's also below the horizon. But on a star chart...
Again, it's not below the horizon. The North Pole is below your horizon.
Is showing above the horizon. Do you see the problems?
Nope.
And it doesn't matter which direction the Earth spins. You're going to still have this problem. Unless the North Star is at the pole. And the sun is at the pole. But it isn't. It's at the equator, this is what they tell us.
At equinoxes, yes. Otherwise, it's going between the Tropic of Capricorn and the Tropic of Cancer.
So, where's it? The equator is somewhere around here.
Yeah, that line just above your hand, going across the middle of the Earth. You can't find it, can't you? Close enough.
I think it's this line.
Yeah.
Might be that line. Whatever.
Hooray!
Doesn't matter. That would be up there. My sun's over here. Day and night. I wouldn't see it in the same spot, and plus it's below the horizon.
North Pole is below your horizon, not Polaris, the North Star.
It's always below the horizon, because like I'm up here, that's below the horizon, right?
Oh, please. I know your name is 420, but please stop smoking. Please.
It doesn't matter which direction you angle the Earth. If the sun is fixed somewhere, and then, because look, the sun would be 90 degrees, right?
Wrong. The Earth is rotating, so the sun will be moving in relative to us across the face of the screen here.
Where the equator is, wherever it is, and that would be 90 degrees from the North Pole.
Yeah, straight up about there somewhere, yeah. Not below your horizon.
So, you know, make a 3D model,
Yeah, sure.
prove Polaris, prove your model,
No problem.
because there's a serious problem with it.
Nope. Yeah, Mr. 420, here is your glow model with Polaris up there. It's not 344 light years, or as you corrected it to be 433 light years. It's just there so you can see where it is. And according to the glow model, if you live, sorry about that one, if you live in San Francisco, you have Polaris at 37 degrees. I live just north of Oslo in Norway. That's just about 60 degrees. And I can see Polaris at 60 degrees. All these observations is pointing towards Polaris from the latitude they're on. And All of them fit the globe model just perfectly. No problems whatsoever. You can go to Jacksonville. That's 30 degrees. It's on the 30-degree line. And you see Polaris at 30 degrees. So that's your 3D model. No problems whatsoever. Everything works like a charm. This is his next video, and it's just as painful. So brace yourselves.
Alright, I'm going to try to explain the absurdity of rotation just by the heliocentric model with Polaris, okay?
The absurdity of rotation. This will be a good one.
So this is not to scale.
Obviously, but yeah, we get it. It's okay.
You know what I mean? But let me explain it. Because we have this argument every day, and you just don't get it. Maybe you need a visual.
Yeah, maybe we do.
Alright, so here's Earth. Say this is Earth. Say I'm right there on the top. Okay? And the top of this lid is the sun, right? Right? And every day, this little battery right here, that's a North Star. It never moves. I have a star app called Star Chart. It never moves. Night and day, it's in the same spot. Night and day. Okay?
Yeah, in our lifetime it never moves, but it was not the pole star a few thousand years ago, and it will not be the pole star a few thousand years from now.
So, okay, I'll put that on the top. There's the top, right? So here's what it looks like to me, is the sun is going like this.
Okay, close enough, maybe. For this model, let it go, yeah, okay.
Every day. That's what it looks like to me. Certain times of the year it goes like more like that, but it's going that way, right? But your model is...
Yeah, we can let that go, sure. We'll be okay with that one.
We are spinning backwards, right? From the sun. And it doesn't matter which way you spin. If you spin that way, that never moves. Spin this way, that never moves. That's Polaris. Okay?
What the hell did you just do? Wow, that's a new one.
It's not hard.
It's not right.
A little kid could understand this.
A little kid could do that better.
But these globe lovers, these globe tards, whatever you want to call yourselves, you just don't get the concept.
Yeah, we get it. You don't.
It's because we're not spinning. Like, this is what we see.
Again, I'll agree with the sun in that model. Sure, close enough.
We see the sun move. We see all the stars go around Polaris. Polaris never moves. Even if we were spinning, Polaris never moves. It's not logical.
Your movement is not logical. Let me show you how it is. Back to the model. And when you had it lying on your table, you have the Earth as the yellow golf ball and the battery as Polaris. Then you rotated it like this and like that. That's not how it works. That's not the way the Earth rotates. The Earth rotates on the polar axis like this. And all the points, all the observations is still pointing towards Polaris up here. So the globe model works. You just need to not to be rude, but please stop smoking. I think that messes up your brain somehow. This is how the Polaris works on the glow model. And yeah, go to San Francisco. You will see it at 37 degrees. Polaris is not up here. That's North Pole. It's 433 light years that way. So I guess this works pretty well. Thank you for watching, everybody. See you next time. Bye bye.